Hi, this is Rebecca Snyder, and welcome back to Applied Algebra. We are going to move on and work with like terms and unlike terms, and we're going to go ahead and simplify them, in other words, put them together. So at the top of the paper here we have some examples of like terms. Notice they have the same letter, that's one of the main components. They both have an x. The number in the front, which is called the coefficient, does not need to be the same. What this 2x means is it's saying I have two x's. I have three x's. On the next one, it's 2ax. Notice both the a and the x are there if the letter is different, so slide on over. This one is ax and this one is bx. So if one of the letters is different, it is a different term. They are not like. If the exponents are different, for instance, if we move back up to 2x and 3x, if I switch that 2x to 2x squared, I change the exponent on the first term to a 2. The second one has an exponent of 1, so those are not like terms. On the third example, I have 2x cubed and 18x cubed. X cubed is the same, so those are like terms. Here I have a y cubed and a y squared, so different exponents, different terms. So on this next one, I have all of the same letters. They're all ax. They're all to the second power for a's and to the fourth power for x's, so we're good to go. If I come over to this example, they're unlike because the exponents of a change, and even though these two are x to the fourth, this one is x to the third. So they're always unlike terms in those cases. So we're going to go ahead and combine some of these together, and we might have to do some stuff ahead of time of combining. So we'll see what we got going on. So this first one says to simplify 4x minus the quantity of x minus 2. So based on the order of operations we did in last section, we should do the parentheses first, but there's nothing to do because x and 2 are not like terms. So we're going to go ahead and get rid of or remove the parentheses. Now what helps me in this case is to think about there is a 1 right here. And that's invisible. A lot of times in mathematics we don't write a 1 down, we just know it's there. Now what's being asked of us here is to do what's called the distributive property. In the distributive property we take whatever's in front of the parenthesis and we multiply it by everything on the inside of the parenthesis. So this is saying take -1 times x. And then it's saying, come on again, take -1 times -2. So I did it by both terms inside the parentheses. Well, -1 times x is just -1x. -1 times -2 is +2. And that other term, the 4x, which is already outside, it just slides on down. Didn't change, didn't do anything, it just came down to hang out. Now I need to figure out what are the like terms. So they don't have to have the same number in the front, the coefficient, but they do have to have the same variable if they have a variable. So here I have an x and an x. They both are to the first power, so those are my like terms. I'm going to combine these. Here it's saying I have 4 of these x's and I want to take one away. So 4 minus 1 is 3, so I'm left with 3 of them. The +2 is the only constant, it's the only one that's a plain number, so I don't do anything with it, I just bring it down. And these two cannot combine because they are not like terms. So that's the best I can do as far as simplifying this expression. So go down to the next one. I see again I have a parenthesis. I can't combine these, they're not like terms, one's a y, one's a z. So what I'm going to have to do is use the distributive property. Again, there's nothing in front, so I'm going to put the invisible 1 just to help me remember. I'm going to multiply -1 times -2y, and then I'm going to do -1 times -3z. So -1 times -2y, negative times a negative gives me a +2, and the y tags along. Negative times a negative is a positive. 1 times 3 is 3, and the z tags along. I'm going to go ahead and bring down the terms that had nothing to do with the parentheses. So the 3y is coming down, and on the back side, the 5z is coming down. So now I'm going to look for like terms. These two in the front are both y, the two in the back are both z, so those are like terms. So here I have 3y's, and I want to add 2 more. So 3y's plus 2y's makes 5y's. I have 3z's, and I want to add 5 more z's, so 3 plus 5 is 8. So now I'm going to look at this and say, okay, I have y's and z's. Are any of those like? And they're not. They're not the same letter. So that is my final answer. It's the best I can do for simplifying the expression. On this one I have 2 sets of parentheses. I do have to take care of them first. I can't combine things on the inside, and that's going to become more and more common now. So I'm going to look in the front, and I have a invisible 1, and I have another invisible 1 there. So what's happening is I'm doing the distributive property twice. I'm doing it here in the first parenthesis, and then I'm going to do it in the second one. So on the first one I have 1 times 7, and then I have a 1 times negative 2x. On the second one, I have a 1 times 5x and a 1 times 1. So a positive 1 times a positive 7 is a positive 7. A positive 1 times a negative 2 is a negative 2, and the x tags along. Positive 1 times a positive 5 is a positive 5. Sometimes you should put these signs in here. They might help you keep track. I don't always do it with the positives, but here I did because it was later on in the expression, and here I didn't because it was the first one. But you need to figure out what's best for you and your understanding. Positive 1 times positive 1 is positive 1. So now we're going to look for like terms. I can see I do have a constant and I have another constant. So I'm going to actually move them together. So 7 plus 1, those are the same terms. They're like terms. And then what else I have that's like is I have this 2x, negative 2x, and this positive 5x. So negative 2x plus 5x are also like terms. So it's okay to move things around when you're adding and subtracting, as long as you take the symbol that's in front of it and make sure it stays with it. So I'm going to go ahead and combine the like terms of the constants. 7 plus 1, I'm going to write the answer over here, that's 8. Then I have the negative 2x plus 5x. So this is saying I owe somebody 2 of them, but I have 5. Well, if I have 5 and I owe somebody 2, once I pay them back, I still have 3 of them. So x plus 3x is the correct answer. Now in mathematics we have what's called proper form, and proper form is to go from highest exponent to lowest exponent with the constants being the last thing. So to put this in proper form, it should be 3x plus 8. Okay, number 4, and we have 2 left. This time what you might notice is that there's numbers in front of the parentheses other than an invisible 1. Now the process isn't changed, we're just multiplying by a different number. So I'm going to go ahead and I'm going to multiply 3 times 6a and 3 times 5. 3 times 6a, 3 times 5. 3 times 6a is 18, the a tags along. I'll go ahead and work on having the signs with me. 3 times 5 is 15. Now I'm going to do the same thing but with negative 5. So I have negative 5 times 2a, negative 5 times negative 7. Negative 5 times 2a is negative 10a. Negative 5 times negative 7. Negative times negative is a positive. 5 times 7 is 35. Okay, one more time. 2 times 10a squared, 2 times 28a. 2 times 10a squared, that's a positive 20a squared. 2 times 28, that's a positive 56a. So actually I'm going to take a little bit of time now and I'm going to rearrange these and put like terms together. So, well, the 20a squared, there's nobody else like that. So I'm just going to go ahead because it's the largest exponent and put it in the front. Now I'm going to look for a's. So I have a positive 18a. That was this one. I have a negative 10a and a positive 56a. So I've combined all of my a's together. Now I'm going to look through my constants. So it looks like I have a 15 and I have a 35, and that's all I have for constants. So now we're going to go ahead and put together those like terms. Nobody was like the 20a squared, so it just stays 20a squared. Here I have 18a's minus 10, so I have 8a's left. 8a's plus 56a's gives me a lot of a's. It gives me 64a's. Then my constants, I have 15 plus 35. 15 plus 35 is 50. And those are already in proper order. Highest exponent 2, then the exponent of 1, then no exponent. And I don't have any other like terms. Okay, the last example in this section, I have a set of parentheses. I do have a number other than a 1, so I'm going to go ahead and distribute that through. So negative 6 times negative y, negative 6 times positive 2. Negative times a negative. There is an invisible 1 right here. You can write it or not. That ends up being a positive 6y. Negative 6 times positive 2 is a negative 12. I do have another term in the problem, so I'm going to bring down that 4y. My like terms are together. They're both up here in the front. 4y plus 6y is 10y. Nobody else is a constant, so I just rewrite it. So don't worry about if you're adding or subtracting as far as when you're going to do the distributive property. Just do it as integers and signed numbers. If you have any questions, please make sure you get a hold of me, and I'll be back for 5-3. Have a good day.